Alright, today we're doing inverse circular functions. Now, what that actually means is instead of trying to find your x and y, we're trying to find the angle that went with that x and y. Okay? So, like I said, so instead of finding, so let's say I give you a value, and I say, hey, where is cosine equal to positive 1/2 in quadrant 1? So from your unit circle, you look at cosine. Cosine is your x value, right? And then where is it equal to positive 1/2? It's going to be 60. That's basically all we're doing for this.
That's it.
We're working backwards. So we're finding the value and getting the angle to go with that value. Okay. So each one of these actually has a range element used once called one-to-one function. Here, there is an explanation right here. So one-to-one function is for every x, there's one y, and for every y, there's one x. So if you notice right here, now there is no x and y's that actually double up. This one right here, I have x's that are different, but the y's are the same. So what it means is the y's are going to repeat. This is not one-to-one. So to check for one-to-one, you have to do a horizontal line test. Back in the day, you guys actually did vertical line tests. Here we're doing horizontal line tests for this to check to see if it's one-to-one.
Is there some? Isn't it called something else? Or
It's one-to-one. All right. So inverse function. Okay. One-to-one. So right here, if it is, okay, defined as this. So you just switching the x's and the y's. Okay. So this is not the power, this is the inverse. So you have to read it as the inverse of whatever it is.
It would be the same thing as tangent.
It would be, yeah, tangent to -1.
Yeah.
Okay, there's
You just ignore
inverse
the negative
tangent.
one, kind of.
Yeah. So it's inverse tangent, says you're working it backwards. There's another way of saying it, it would be like arctangent. It means the exact same thing. So it's another way of saying it. Alright, replacing, solving, here's the inverse. Okay, you guys have all these in your notes, so I'm not going to try and go through that too much. Now, for sine or arcsine, your interval is important. Okay, this is going to be the key thing that you're going to do. Sine has an interval, it's going to be from -π/2 to +π/2. So that's quadrant what? This is, think about it, from -π/2, that means it's backwards, right? So -π/2.
Oh, so it's in quadrant 4.
It's quadrant 4, very good. It starts over at quadrant 4 and goes all the way to quadrant 1, right? So from quadrant 4 to quadrant 1, and these brackets right here mean what?
Oh, okay, I get it.
It stops. It's going to equal to. It's allowed to equal those numbers. If there's a parentheses, that means it's not going to be equal to. Bracket means it's equal to. All right, so this one right here. This is kind of like what we're talking about. So arcsine. So I'm going to actually rewrite this first. So arcsine and my interval I know is going to be from -π/2 to +π/2.
And this is gonna be every single time.
Yeah, for sine. Okay, so it's going to be from there to there. Now, my arc, so I'm going to actually do the inverse of this. So I'm going to do the inverse function, okay, to the -1 thing. Yeah, to the -1, right?
Yeah.
Okay, so that's the arc of this. So I'm going to rewrite this instead. So it's basically going to look like this. It's going to be theta is equal to sine, -1, inverse sine of 1/2. Now, I'm actually going to work it backwards. So I'm going to turn it into this way. So you rewrite this by switching your value over here with this value here. So it's going to say, where is sine theta equal to 1/2 in these quadrants? That's what it's asking for. Okay, so it's going to be 30 degrees. Now, if this is given to you, your interval in radians, like this, therefore my answer has to be in radians also, right?
So pi over 6.
So it would be pi over 6. So this one is going to be, so my theta is pi over 6.
Are you gonna do another example?
Yeah.
Okay.
It's basically, I'm giving you something,
Yeah.
find it on the unit circle in the interval that is given to you here.
Yeah.
That's basically it.
And since it's sine, it's always good.
It's always going to be there. Now, if you have your reference sheet also, your intervals are on your reference sheet for this.
Oh, okay.
Now, same thing, interval. It's going to be from negative pi over 2 to positive pi over 2. So if I were to rewrite that, it's theta equals so negative 1 is equal to sine theta. That's a negative there. Right? So, where is sine theta equal to negative 1?
180.
Alright.
No, not 180. Sorry.
What's my interval?
Yeah.
It's only from quadrant 4 up to quadrant 1.
So
yeah,
270.
Okay, but now, if it's this interval, I don't say 270.
Yeah.
Because
3
look,
pi
it goes
over 2.
backwards, right?
3 pi over
3
2.
pi over 2. So it'd be negative.
Yeah, it has to be negative, right? So, my unit circle looks like this.
I'm confused.
So, it goes up to pi over 2, and it goes down to negative pi over 2. So, it's only allowed to have anything from here to here. So, you guys are right by saying 270, or you said what? 3 pi over 2. But I don't want that as my answer, right? Because I need to have the pi over 2. Okay, good. So what would I do? I need to find here. So I don't want that, so that means I need to do what to actually get this back here?
Count backwards.
Count backwards. So now, if I have that, it's supposed to be 270. I want coterminal, but I want it to be negative.
So you would subtract 360.
Subtract 360. That'd be negative 90, wouldn't it? Okay, so on my unit circle for this, it would be down over here, wouldn't it? Straight down. So it's going to be negative 90, which would be the same as saying negative pi over 2. That's what it's going to be. So it has to only be from here to here. So if I'm looking at this on a graph, I'm only looking at it from here to here. Okay, so if we have a window on my graph and actually trying to graph this, it would look like it's going to be somewhere between here and here. So this is a place in which that over here, my values are negative, over here, my values are positive. So my interval is going to be from here to here, so it's going to be down over here. So my theta here, negative pi over 2. I lose anyone?
You lost me a long time ago, but I think we're good.
Okay. Are you okay? Or did you find the 270?
Yeah.
So you were okay with 270, right? But since my interval 270 is too big for this, right? 3 pi over 2, isn't that way over here? So if I'm thinking about this on a number line, 3 pi over 2 is way over here, isn't it? And I'm only allowed to have my answer somewhere in between here and here. So what I did is, if it's supposed to be 3 pi over 2, and I want to find coterminal, but I want to find it way over here. So I'm going to subtract. What's the equivalent of 360 but in radians? Instead of subtracting 360, what's a whole circle in radians? 2 pi. So that's basically what I did. So from here, I know it's here on the unit circle, right? So subtract 360 to put my interval over here. So it's going to put me right over here. Does that make a little bit better sense? Or subtract the 2 pi to get to there? Alright, so this one right here. Is there any place on my unit circle where it's equal to negative 2? So negative 2 equals sine theta. Is there anywhere where it's equal to... What's the radius of my circle anyway? The radius.
Oh, 1.
It's the radius of the circle is always 1, isn't it?
Oh, yeah.
The radius is always going to be 1. So the biggest number I can ever get out of there is 1. Because if you think about it, in my Pythagorean theorem, my r value is the largest, right? So the r is always the largest number, but for this case right here, since r, my radius is 1 on my unit circle, there's nowhere on my unit circle where it's going to come out to be 2. Okay, so this one right here is going to be no solution here. Now, if you are questioning me on this, do this in a calculator. Everyone's set to degrees right now, right?
What do we do?
Okay.
We put
Inverse sine. Do your trig. Put negative 2.
Non-real calculation.
There we go. Does that make better sense?
So we can just put it in no matter all the time, and we'll get an answer.
Yeah.
For this, it's supposed to be degree or radian.
We're in degree right now,
Okay.
and then you would convert to radian when you're done. So basically, everything we're doing is going to be in degree, and then you convert to radian for what you're doing. Okay, so for right here, my domain for sine and arcsine is going to be from negative 1 to 1. So that's the biggest it could be. The range is always going to be from negative pi over 2 to positive pi over 2. All right. Okay, so now for arccosine, it's going to be from 0 to pi. Okay, so let's take a look. So my interval is going to be from 0 to pi. And so it's theta equals cosine negative 1 of 1. So we're trying to see where 1 is equal to the cosine of theta. So where is cosine theta equal to 1? It's going to be 0, right?
Is that your answer?
Yeah, my answer is 0. Because on the unit circle at 0 degrees, or 0 radian, theta equals 0. Alright, again, theta is equal to inverse cosine of negative rad 2 over 2. So from my interval from 0 to pi, let's see, negative rad 2 over 2 equals cosine theta. So where is cosine equal to negative 2 over 2? Oh, I'm sorry, negative rad 2 over 2 in the interval from here to here.
3 pi over 4.
3 pi over 4, that's quadrant 2, isn't it?
Yes.
Okay, so this is quadrant 1 and quadrant 2. Easy?
When does the hard part come in?
I know.
Okay, so again, domain. So biggest numbers I can get there are going to be from -1 to 1. And my range, 0 to pi. Tangent. Domain. -infinity to +infinity. So it's all of it. Range. So is it like the sign?
Yeah.
It is like the sign, but what's different about the sign?
The domain. Oh.
Parentheses. This means that it cannot be equal to -pi/2, and it cannot be equal to +pi/2. It can go up to it, but that cannot equal. My answer cannot equal -pi/2, and it cannot equal +pi/2. Okay, cotangent. So cotangent, same as tangent right here. And then the range is from, so it's kind of like, this one's kind of like cosine, right? But unlike the other one, it cannot equal 0 and it cannot equal pi. So cotangent goes with cosine, sine goes with tangent. And then the inverse ones are always tricky. So you guys have these on your reference sheet. You also have them right here. So, arctan. So let's see, arctan. Interval went with sine, right? The interval for sine was going to be from -pi over, ooh, wait, not bracket. Parentheses, -pi over 2 to +pi over 2. And so if I were to rewrite this, so it should be, see, 1 is equal to tan theta. Now, where is this equal to 1? Remember, tangent is the ratio of y over x, right? The cosine over, or sine over cosine, right? 45 degrees or pi over 4, right? So here, theta equals pi over. Theta is equal to pi over 4. I know, it's ugly, sorry. Last one. I think this is the last one, because I don't think we have a different part to this. Alright, so this one right here. Secant. So now, this is going to be 2 is equal to secant theta. Now, remember, secant is the reciprocal of what?
Cosine?
Cosine. So if secant is the reciprocal of cosine, so it would be the reciprocal of this, right? So it's going to ask where, basically, but with the restrictions, it's basically asking, what? I don't know why it's doing this. There you go. It's basically asking where cosine theta is equal to 1/2. Now, if we go back to the restrictions on secant, let's look. Here's secant right here. So the domain, okay, it means union. It means that it starts at -infinity, goes to -1, and then it skips and starts up again at +1 and goes to positive. No. No, it's everything. So if you remember what the graph looks like, so if we had a graph and it was something like this, there's the cosine. The secant, which is reciprocal of this, would go this way. Do you remember those? Yes. So it would be, this is right here is my -1, and this is my +1. So it would be from down here to up here. But I'm looking at this thing over here, secant over here. So secant is the same thing as what we had for cosine, right? But I'm not allowed to have an answer at pi over 2.
Oh yeah.
Okay, pi over 2 is not allowed to be your answer. Because if I'm looking here, if this was pi over 2, that would be an asymptote
Wait,
for
but
this.
cosine at 1/2 is pi over 3.
Okay, so yeah, that's what I'm trying to say though.
Oh.
So my restrictions went to that, so it's the same as cosine, but I cannot have an answer at pi over 2. So right here, so where's cosine equal to 1/2 in
Pi
my,
over 3.
so that's gonna give me theta is pi over 3, right? Alright, I think that's it, right? Yep. Example 4 is later.
Yeah.
Alright, you guys.